Lately, if you've been following any blogs, it seems that larger web apps that began a few years ago are finally hitting some big growing pains. In both the PHP and Ruby communities, companies and developers have been trying to remember all that they've intentionally left behind from Java or C# so that they can try to restore some structure to their rapidly developed application. And that's not to say they did anything wrong by any means. They likely created a minimal viable product or something close to it, got it out the door, and started producing revenue so that they can keep producing more features. It's a trade-off of the agile workflow. You're free to cut corners to start with, but eventually you may have to rectify those situations. One of the trade-offs that people quickly jump to, and that I fully support until it becomes a problem, is an active record implementation of a norm, like Eloquent for Laravel, Propel, PHP Active Record, the first version of Doctrine, and there's a few more examples out there. They very quickly allow you to get up and running with various domain objects having direct access to the database abstraction layer, and having immediate CRUD access. CRUD being create, read, update, and delete. The active record style ORMs allow you to make direct queries like these anywhere you'd like. If these are scattered all over the application, like in controllers or relations or libraries or other models, you're going to have a heck of a time if you need to change the behavior, rather than having all of this logic contained in one spot. So if you use one of these finders like this on a typical ORM and return a collection of models, you'll have X number of instances of that model returned. At that point, you're free to use any instant method, whether user-defined or inherited from the model's base class. Part of the issue is that at this point, it's hard to see what methods are available to the developer. Another huge part of the issue is that what was once helping is now hurting. The user entity is tied directly to the persistence layer. This can become a headache to maintain if you have a lot of complex business logic, and even more of a pain to test since you constantly have to try to mock out the database connection inside of your object for testing, or try to mock out static methods. In addition, namely in relational databases, queries can start getting very high traffic since several representations of the same row from the database can exist in the system. These instances are not managed as one entity, so the query to fetch an object has been executed each time, so there is no central cached location to grab the reference from instead. So before we jump fully into making a repository, let's look at an example model and controller to see how we can start getting it ready to be split out into a repository pattern, or at least making it more manageable in larger code bases. So we'll open up user.php and see what this is all about. Up top, we have a user class that extends from ORM. We have a static data store property that acts like a database, an overloaded constructor that calls its parent, then transforms a created@at property into a datetime object, and finally a created@year method that will return a boolean of whether the user was created this year or not. The actual ORM implementation isn't very important to the code base, so I'm just going to skip it for now. Our example.php file will require a user class, making a query for 2 records that were created before 2014. It'll then output the results to a table. The results look like this. Pretty straightforward. So let's stir things up a little bit. We've been told we're likely moving to MongoDB at the end of the year, but we may try out Postgres in a few months, and we need to get our data access layer cleaned up. I'd like to say this kind of stuff doesn't actually happen in the real world, but unfortunately, I've seen things extremely close to this example. So let's see what we can do in the interim. If we assume our example.php is something like a controller, we know we shouldn't be making this query explicitly. We should be calling a method on the data object to give us the data that we want in a way that we can assume is safe. Using one method is often a lot safer than trying to use 4 and hoping none of them change. Let's cut this query and change it to user equals get all created before. We'll pass in 2014, and then we'll pass in an associative array with the key take set to 2. Over in user.php, we'll create a public static method named get all created before, which will accept 2 arguments, year and options, which is optional. We'll then write out query is equal to static query where created@at is less than year. Then we'll check if option take is set, and if it is, we'll call query take and pass in options take. We'll then return query get. Now when we run our example script, everything is still the same, but we've lowered the example script's reliance on the user class's methods accepting a fluent and chainable interface. Now let's look how to take this a step further and transition this into a repository implementation. We'll yank out our definition for get all created before, and then we'll open up user-repository.php, and then inside of the blank user repository class here, we'll paste this method, change this back to an instance method, and we'll change static to user. Next, we'll define find, which will take in an ID, and it's going to forward the call to user find. And then we'll do the same with find all. Okay, so that'll be it for a very basic repo as a first step. Now in example.php, we'll require user repository.php, and then we'll instantiate a new user repository and store that to repo. And then we'll change user : to repo arrow and save. Running again, We still get the same results we've had, but now we're running through our repository. So this kind of refactoring will allow the devs to get ready for the switch to Mongo or Postgres. They're isolating all of their query logic for users within one spot, the repository, so they'll be able to swap out implementations easily. In fact, we can slowly build up a Mongo repository object alongside of our current user repository, and then just swap out when we need to. Now you might be thinking, but you're still using the ORM, you just wrapped it up. And I will tell you, yes, that's exactly what I did. It's in isolation now. I can change a method one at a time and ensure I'm not going to orphan off some calls somewhere. The user object still technically has the ability to do all of the CRUD operations on its own, but as long as you avoid using them outside of the repository, you're well on your way to splitting these two items apart. When you have another non-active record implementation ready to go, you can simply turn the user into a dumb entity that doesn't know about anything related to the database layer itself. It'll just know about its own logic, like if it was created this year. So hopefully that crash course was enough to get you started. Our next episode is going to be focused on a concept similar to this and a recurring theme I've been trying to present. Having your classes do only one thing. We'll be covering the single responsibility principle.